let's start our next section, which is about arc length. So let's say we have a curve y equals f of x, and I'll draw a graph here for you, just some function, it doesn't matter which one. Let's just do a parabola, and I want to find the arc length from between x equals a and x equals b. Okay, so I want to know what's the length of this section of the graph. So it turns out there's a really nice formula for this. So I would say the arc length of f between a and b is, I'm going to call arc length s. It's the integral from a to b, the square root of 1 plus f prime of x squared dx. Now this works for a function. What if you have x as a function of y? So maybe it looks something like this. And now you're going to look between c is greater than or equal to y is less than or equal to d. So now your range of values are on the y axis from c to d. And I'm going to have, I want to know the length of that section right there. So I want to call this function, I'm not going to call it f because I used that before. Let's call this g. So then the arc length of g between c and d is, again, I'm going to use s for arc length. It's the integral from c to d, the square root of 1 plus g prime of y squared dy. So it's a very similar formula, but now your integral is in terms of y instead of x. Alright, so let's try to find an arc length here. So let's find the arc length of the function. Let's go with just a line for now, 2x plus 3 from the point 0, 3 to 2, 7. So here's my function, and my arc length formula, I need the derivative of that function, so let's find f prime of x. The derivative is 2, so let's set up our formula for arc length now. S, it's the integral, the square root of 1 plus f prime of x squared dx from a to b. So let's plug in. I look at my points. I'm going from the point 0, 3 to the point 2, 7. So my bounds on my integral will be from 0 to 2. The square root of 1 plus 2 squared dx. So this is just going to be the square root of 5. So when I find the integral of that, it's going to be square root of 5x and you're going to get 2 times the square root of 5. And that's the length of that segment of the line. Now I do want to make one note here. Because f of x is a line, this is the same as the distance between our 2 points, 0, 3 and 2, 7. So an alternative way you could have done this problem for this case, again, only for this line, you could use your distance formula and find the distance between your 2 points. So let's find the distance between our 2 points. Two squared plus 4 squared, it's the square root of 20, which is 2 square roots of 5 if you simplify it. So it did work out to be the same. Again, this only works because our function was a line. That's the only reason that it worked.